My name is Mirta Lucas and this is my final project for CSC 578. I decided to choose GAN, Generative Adversarial Networks. I started to explain GAN in class, and GAN consists of two convolutional networks, a generator network and a discriminator network. Both are competing with each other. The generator is trying to deceive the discriminator by producing fake images from noise, and the discriminator is trying to detect those fake images or real images. We also in class saw the basic architecture: GAN receiving noise, discriminator receiving fake or real images. The training is here, where the generator receives noise, produces a fake images. The discriminator receives those images and produces results. Both the results is compared with the ground truth, and the generator loss is produced to adjust the generator parameters. This is the discriminator training. It has to be trained for real images, and the same way it has to be trained for fake images. The discriminator outputs are compared with their respective ground truths. Real loss and fake loss are generated and are backpropagated to the discriminator to make the adjustments. That's what we saw during class. I was able to produce images using the basic GAN, but from the last time to here, I've been working in InfoGAN, which is a basic GAN, but receiving this time not only noise but also label and code randomly generated, and the discriminator receives fake images and real images, and the discriminator this time is going to produce output for fake or real, a new label and a code. The training for the generator is not changed in the InfoGAN. It's still going to train the generator the same way, the discriminator the same way. The only difference in InfoGAN is that there is a new training. The new training involves comparing the label that was fed to the generator versus the label that the discriminator is producing. Both are compared in what is called a label, and it's generated with a label loss, the same way the code entered for the generator and the code produced by the discriminator produces a code loss. Both loss, the label loss and the code loss, are fed towards the whole network and adjustments are made. That's what is the basic InfoGAN. But why is called InfoGAN? Because besides receiving noise, is going to receive more information corresponding to the label. The idea behind this was that you could produce at will a number that you fed in the generator. For instance, if I wanted a number 2, I wanted to produce a number 2, or number 7, I wanted to produce a number 7. But after training for 200 epochs, this is what I got. I requested a 2 and I got a 7, a 4 and a 1. So after reviewing the basic architecture for InfoGAN, which is this, I noticed that there is something missing here, which if you see, yes, the generator is receiving more data, which is label, and the discriminator is producing labels, but there is no connection between what the real labels for the images are associated with what the generator is using. So that was the small change I made to the InfoGAN. This is my small change. If you see this notice, if you see this, the generator is now, instead of receiving random noise, is receiving data coming from the real images. So it's receiving real data, and there is no more change in the architecture. But this time, in the training part for the generator, I am feeding the labels, producing the fake image. The discriminator is going to produce the fake or real decision, but the new label. At this time, I'm going to compare this real label versus what the discriminator produced, and there's going to be a generator label loss. This generator label loss was not before, so I'm including that. I'm also adjusting that parameters for the generator using this additional information. The discriminator will have this modification as well during the training of the discriminator with real images. This time I will provide the real labels, and the discriminator will produce new labels, and there will be a discriminator label loss, which was not before. So then we have 3 losses that are included, are considered to adjust the weights of the discriminator. The information is not changed. This has not changed in my version, which I called extra conditional GAN. And this is after training for 200 epochs. This is what I got. I requested 2 and I got a 2. I requested 4 and I got a 4. And finally, if you see, there was an additional parameter called code. From left to right and from top to bottom, you see there is a variation between thickness and rotation. It's appreciated in both number 1 and 4, and the quality is also good. These are my references, and I have included all my code in D12, which can reproduce everything that I'm presenting here. Thank you.